This is pre-calculus section 5.4 on the sum and difference formulas part 2. And we're starting off with this problem which says to verify that the left side is equal to the right side. The left side, there's a lot of stuff, so that's where we're going to do most of our work here. And we're going to expand these out by using sum and distance formulas. First of all, starting with this one. So expanding it out, it's cosine theta times cosine of 60. And then the minus sign means plus, that's what's inconsistent here. So we have sine of 60 times the sine of theta. So there is that one all expanded out. Now we'll go on to the other one. And I want to expand out this part. So expanding that, we have plus. And now it's cosine 60 cosine theta minus sine of 60 times the sine of theta. So we expanded both of those out and haven't touched the right side at all. And we're looking at this problem now and seeing what is going to actually eliminate or reduce from this one. I see in this one that there is a positive cosine sine 60 theta, cosine theta, another positive cosine 60 cosine theta. So together that makes 2 cosine 60 times the cosine of theta. However, this is a negative sine 60 sine theta and a positive sine 60 sine theta. Those two are going to cancel each other out. So here's what we have on the left side. And the cosine of 60 is actually an exact value. The cosine of 60 is equal to 1/2. So then if we multiply the 2 times the 1/2, that just comes out to the cosine of theta, which is equal to the right side, and that is also cosine of theta. And here is our second example of verifying. Both of these sides look kind of confusing, but as I look on the left, there's a tangent sum and a tangent difference formula. So I'm going to expand out those. So I did all of the expansion for tangent of x plus pi, tangent of x minus pi. So there are those expanded out, again, just simply using the formulas. And tangent of pi is an exact value. If we think about pi, pi is all the way to the left. Tangent is sine over cosine. The sine of pi is 0. So the tangent of pi is also 0. 0 over negative 1, which is 0. So this is 0. This is 0 as well. This is 0 and this is 0. So the first fraction has just tangent of x divided by 1 minus 0, because 0 times anything is 0. So there's the first one. And for the second one is tangent of x minus 0 in the numerator divided by 1 plus 0, again because tangent of pi times that makes that whole product down here equal to 0. So on the left side we have tangent of x plus tangent of x. That's simplified down a lot from the original. In other words, that makes it equal to 2 times the tangent of x. That looks very simple. The right side doesn't. So I'm looking to see how can I make the left side equal to the right side. And one thing I notice on the right side is that we have some fraction, and in the denominator is tangent of x. So what I would do next is rewrite this as tangent squared over tangent of x, and I'd probably even put this 2 up in the numerator with it. So now there's the left side, and compared to the right side, they're looking a little more alike. And I remember that 1 plus tangent squared is equal to secant squared, or in other words, tangent squared equals secant squared minus 1. This is a variation of one of our Pythagorean identities. So then, making that substitution is 2 times the quantity secant squared x minus 1 over the tangent of x. Now if I look at the right side, that's almost it. So we'll do one more step. Distribute that 2. It's 2 secant squared x minus 2 all over the tangent of x. And that is what was originally on the right hand side. So then this problem is verified. Here's our next type of example. The directions say to solve this from 0 to 2 pi. In other words, our answer needs to be in radians. We're only looking for one rotation around the coordinate graph. And we want to solve this. Initially, it looks really messy. I can't solve this right away. It doesn't say x equals something simple. So we're going to expand to temporarily make it look more confusing in order to simplify it down. So I'll pause this for a second, expand out the left side of this one, and then come back. So I've done all the expansion. This sine difference formula can be expanded all the way out to that. This sine sum formula can be expanded all the way out to that. Now we're going to look to combine those together as best we can. And to start off with, I'm looking for something that might cancel out. Is there anything that's in one of them that's a positive and a negative in the other one? And it looks like this is a negative and this is a positive of the same thing, so those eliminate each other. These two are exactly the same and they're both positive, so we have 2 of those sine x times cosine of pi over 4. So there's the left side. I can simplify this down even more here in a moment, but on the right side, I can simplify. The directions don't say to verify, so I can work on both sides simultaneously. And I know that this is almost a Pythagorean identity. In other words, if we factor out a negative, or -1, it would become sine squared of x plus cosine squared of x inside of the parentheses. And the reason why that's nice is because sine squared plus cosine squared is equal to 1. In other words, instead of having this right side equal to this, which is very vague, well, it's now equal to -1, which is a lot simpler to look at. Going further in this one, working left side to right side now, I divide both sides by 2. So now the right side is -1/2. Cosine of pi over, and we still have the sine of x, the cosine of pi over 4 is √2 over 2. So now we're getting closer to having something that's manageable. And I want to solve for x. Multiply both sides by 2 over √2, so on the left side you only have the sine of x. And on the right side, to be consistent, we're going to multiply by 2 over √2 also. Those cancel out and we get -1 over square root of 2. What angle between 0 and 2 pi has that? Well, I don't know any of those, but I do notice that I have a radical in the denominator, so I'm going to rationalize the right side, times by √2, times by √2, which makes it -√2 over 2, and now this can be solved. If I think about it on the graph, it says the sine is negative something, so I'm dealing down in the third and fourth quadrant where sine is negative. The sine has an absolute value of √2 over 2, so if I were in the first quadrant, this angle would be 45 degrees, or pi over 4 radians. But it's not negative, so bringing all this together, my answers are the angle in the third quadrant that has a reference angle of pi over 4, and the angle in the fourth quadrant that also has a reference angle of pi over 4. That takes into account the negative as well as the reference angle of √2 over 2. So for the answers, there's one of them. This angle is pi plus pi over 4, which would give us that x equals 5 pi over 4. The other answer that we're looking at starts here, goes all the way around to that point. So I could say that it's pi over 4 short of getting an entire revolution, or 2 pi minus pi over 4 would give us the other answer at 7 pi over 4.